Hello, Michael. Can you hear me?
Uh, can you hear me?
Yes, I can hear you.
Okay.
How are you doing?
Good. Thank you for. I'm sorry I didn't. I sent the instructions or confirmed it too quickly. I'm sorry about that.
No, no worries, no worries. That's okay. It's a bad weather today, and electricity has gone, so I can't turn on my cam right now. For next time, for sure. Sorry for that.
That's absolutely fine. No worries.
Okay, would you like to tell me your background in maths? Like, did you learn calculus stuff,
Yeah.
everything?
Um, I learned a bit of calculus very long time ago. Recently, been doing a bit more in yeah, like linear algebra, some differential equations, but um, some statistics, but not much. So I know the basics.
Okay, that sounds good. So the very basic and the first topic in differential equation is separable differential equation. You know about differential equation, like equations involving derivatives are called differential equations, and separable differential equation is a differential equation that can be written in the form of dy by dx equals f of x times g of y, where f of x and g of y are the functions of variables x and y, and you can separate the variable. Okay, I would like to try a couple of basic problems with you, and I would like to revise the concepts of derivatives and integration, and then we can go ahead. So that's important. For example, we have dy by dx equals simple from x squared over y. So the first step is to separate the variable. You have to write y with dy and x with dx, right? So
Mhm.
how can we bring this y on the left side? Just multiply y on both sides. We would get y dy. And if you multiply dx on both sides, it's going to be x squared dx. Now variables are separated. Y with dy and x with dx. Now you have to apply integral on both sides. Integral on both sides. What is the integration of y?
I don't know.
Did you remember that?
No, that.
Okay, it means, okay, hold on. It means we need to recall all the formulas for derivatives and integration. That's important because in differential equation, you have to do derivatives, integrals, at the same time in a problem.
mm,
But okay, no problem. I have to revise those formulas. So let me revise just two basic formulas in derivative and integration. That was power rule. So whenever we have x to the raised per n, its derivative was n x to the raised per n minus 1. That was power rule. For example, we have x to the raised per 3. Its derivative is 3x to the raised per 3 minus 1, which is 3x squared, right?
yep. I'm just writing it
And
down. Yeah.
yeah, sure, sure, sure. And now I'm talking about the power rule for integration. Integral means antiderivative of x to the raised per n dx. It is x to the raised per n plus 1 over n plus 1. Means you have to add 1 in the exponent and divide with the same exponent.
Okay, so you're dividing the by the exponent, or
Yeah, for
yes.
example, we have x cubed, integral of x cubed dx. It's going to be x to the raised per 3 plus 1 over 3 plus 1. Simple, which is x to the 4 over 4, right?
Mhm.
And for example, we have 5x squared dx. It's going to be 5 is just constant. X to the raised per 2 plus 1 over 2 plus 1. So it will be 5x cubed over 3. So this dx or dy or dt, sometimes you have dx, dy, dt. That represents that you're going to integrate with respect to x. Dy represents that you are going to integrate with respect to y. Dt will represent that you're going to integrate with respect to t. So now look at this one, y. This is just y. It means this is y to the raised per 1. So its integral is going to be y to the raised per 1 plus 1 by using the formula over 1 plus 1 equals x to the raised per 2. Its integral is going to be x to the raised per 2 plus 1 over 2 plus 1. plus constant of integration. So let's simplify that. Y squared over 2 equals x cubed over 3 plus c. Or if we want to write this equation in terms of y, like y in terms of x, so we can just multiply 2 on both sides. It's going to be y squared equals 2x cubed over 3 plus 2c. Plus 2c, let's say this is 2c. And this is, let's say, small c, right? We can write 2 over 3x cubed, and this is 2c. I can just replace it with a capital C. No problem, because this is overall constant. 2c is overall constant, so I can just replace it. Or you can sometimes write C1 like this, 2c1, and then you can replace it with C. Does it make sense?
Yeah, yeah. It's kind of like matrices, or sorry, arrays, kind of using a capital
Yeah,
to
yeah,
kind of
exactly.
represent it.